Hello friends, so I wish you a very happy new year 2024. So in this video I will talk about the FONLL calculation. So FONLL calculation for the heavy quark production. So FONLL stands for the fixed order, so FO fixed order next to leading logarithm. So once you click on this link, then you will go to this page, and this allows you to calculate the cross section for the heavy quark. So here basically you can go through this text. Basically there are several updates. This calculation is basically by Cacciari. So then you can basically go through the details of the reference. So what is the values used for the calculation. See, these all things you can go through. So I will tell you how to get the cross section. So in this, if you go in this link, then you can find that there are several options for the collider. For example, LHC, PP13TeV, and then you can also see there are several collider options, REEC, and then others also in different energy ranges, so different center of mass energies. And then also, for example, now I choose the LHC PP13TeV, and then the PT maximum is 300 GeV. And then there's also PDF used. There are this is NPDF 30 and NLO, and then also there's one more option for the PDF CTEQ 6.6, and then here I am using the default NPDF. And then it also have the perturbative order. For example, FONLL basically which stands for fixed order next to leading logarithm, or there's also one option NLO. So here you can choose the production cross section. For example, I want to study the CERN to hadronic state is D0. You can also choose the D0, D plus or D star depending on your choice what you want to get. And here you can get the different options for the cross section. So I have the cross section d sigma over dpt, cross section differential cross section with respect to pt. And then also we have a differential cross section in eta, so d sigma over d eta, and there are other options also. So I will show you in two cases, one over d sigma over dpt and then the d sigma over d eta. And then I will get the I want to get the central predictions only, and there are several other options you can check. And I want to take the central prediction. And then you can choose the minimum pt. For example, I can choose 0, and then the maximum pt you can choose for example 50. Okay, and then if you want to use the rapidity, then you choose the by, or if you want to use the eta, then I would choose the eta for according to the detector acceptance. So for example, I will choose the -4 to 4. Okay, so now it has a detector coverage of -4 to 4. And then basically you can also choose the number of points, how many points you want. So I will choose the number of points, for example 100 in this case. And then you can increase whatever you want. If you want 1000, you can also do the 1000. So then it's done basically, and it will basically use these default values for this calculation. So then you can go through if you want to modify some values, then you can also go through the actual code. There you can modify these things. So then I will submit it, and then it will show the cross section. For example, let's split it's calculating the cross section, the d sigma over dpt. So now you can see it gives also the information on the top, and then you can see this information, so all the information. And then basically you can also see quark is CERN, and then it's in the d0. And then there are other options like the center of mass energy 6.5 TeV for the one beam, and the another beam 6.5, and then all the PDF set, and then the eta and the pt maximum, and the cross section values in the picobarn per GeV. So now what I will do, I will basically select, and then I will put in my text file. So for example data, I will just remove the older one, and then I will paste this new data. And similarly I will also go through the eta. For example eta, now I want d sigma over d eta, So then I will choose for example 0 to 50 same. Now I want minus 4 to 4 in the eta, and then I am using the eta. Now in the eta, how much binning you want? For example, it's I want a bin width of 0.1, so it should be total width is 8, so I will put the 80, so that bin width is around 0.1, and then rest of the settings I am using the same. Then it will show you the result. So now I got the results in differential in eta. So you can see the eta and then the central value of the cross section. Now you can see the d sigma over d eta. So here the unit is picobar. So I will select this also, and then I will put in this the eta file, and then I already wrote a macro for the draw eta and draw pt, which will basically draw it. So I can draw it now in this. Now if I plot root minus draw, which basically read that two columns, draw pt, draw pt. Now you can see that the cross section, so d sigma over dpt as a function of pt in the picobar per GeV, and then this is basically I put as a legend C2Z0 and then pp at 13 TeV. So in this way you can get the cross section, differential cross section as a function of pt. And the next one is I already mentioned, you can also draw the eta, because I have already data for eta in this text file. So then you can also plot it. So now you can see also eta d sigma over d eta. So you can see that the unit is picobar, and then in the eta, so here if you just see the number of points is 80, as we already put in the during the simulation, during the calculation. So in this way you can calculate the cross section for the heavy flavor using this code, and I will put the link of this code into the description box, so you can use for the calculation of the cross section. Okay, thank you.